Hello everyone. Let us try to understand the operations on signals. What are the different operations we can perform on signals? Generally, on numbers, we do perform many operations like addition, multiplication, subtraction, division. Similarly, we can also have the operations on signals. Let us try to understand what are the various operations we can perform on signals. So, operations and signals. When I say operations on signals, I mean operations on continuous time signals default. So generally these operations on signals can be two types. We can have this as operations on dependent variables, can have operations on dependent variables and the operations on independent variables. Let us try to understand what exactly mean by the operations on dependent variables and operations on independent variables. When I say this dependent variable, and this is independent variable. Now if I say it is y of t as an example, if I say it is an example y of t is equal to a into x of t with an assumption that simple equation y of t is equal to a into x of t. Now this a is the magnitude of this particular x of t. This is magnitude, we know this is a magnitude or amplitude of the signal, and which is a dependent variable, Similarly, this is the time, which is nothing but independent variable, So what are the operations you are trying to perform on this particular magnitude called dependent variable? That all the operations comes under operations on dependent variables. And what are the operations you are trying to perform on the time small t? That all will be considered as operations on independent variables. So if you try to do any operation, then any operations on this particular small t, that is considered as operations on independent variables. And if you are trying to do some operations on this a, capital A, which is magnitude of the given signal x of t, that comes under operations on dependent variables. So let us see what are the different operations we have on the independent variables and what are the different operations we have in the independent variables. So if I say operations on dependent variables, there are three operations we can have. One is addition or subtraction, we can say addition of signals, addition or subtraction of signals. Second is multiplication. Third is the amplitude scaling. We call it as amplitude scaling. These are the three different operations which comes under operations on dependent variables. It means that when you are trying to add two signals, x1 of t and x2 of t, if I say addition, the amplitudes will be taken into consideration for adding the signals. Similarly, when you are trying to subtract one signal from the other signal, in that case also we will take the magnitude into consideration for the subtraction. And when you are trying to multiply two signals x1 of t and x2 of t, these magnitudes will be taken into consideration and multiply them, and based on that we will try to sketch the resultant signal. So when you say scaling, amplitude scaling means we may increase or decrease the amplitude of the given signal depending upon the situation. So all these operations, if you look at addition, signal subtraction, signal multiplication, amplitude scaling, all these four operations focuses or works on the independent variable called A, or magnitude of any given signal. So similarly, we have operations on independent variables. Operations on independent variables. These are one is time folding. We call it as time folding, or we also call it as time reflection. Second, we can call it as shifting, time shifting. Third, time scaling. Now, if you look at these three operations, all these three operations works on this particular small t: time folding, time reflection, time shifting, or time scaling. All these three operations just will be performed on this particular independent variable called time, which is known as. So these are the three different operations which can perform on the which can perform on the signal on the particular time, which is known as an independent variable. So let us also try to understand with a small example how this addition, subtraction, multiplication operations on dependent variables will be considered, and operations on independent variables are considered with the simple examples. So now let me take a simple example. Say x1 of t, I want to sketch, say to sketch example 1. Say sketch y of t, where y of t is equal to say it's u of t plus 1. This is a simple example. Just I am trying to explain you how addition operations will be performed. Now you know u of t is a signal. U of t is a signal. This 0, 1, and this is 1. This are t, and we are adding this plus, and we are trying to add a constant DC component for the signal, which is nothing but 1 for it, 0, and this is t again. So this is u of t plus 1. 1 is, since minus infinity to plus infinity, it will be 1. Now if I try to add these two signals, the resultant signal will have expression y of t, that we try to understand how this y of t can be sketched. So now we'll try to divide from minus infinity to 0, the first signal u of t is 0. So 0, the second signal from minus infinity to 0, this is 1. So 0 plus 1 will becomes 1. Addition we are taking it as, since we are taking the magnitudes of the two signals into consideration for addition. This is 1. Similarly, when I say from 0 to infinite, this is 1 and this is also 1. So 1 plus 1 will becomes 2. So that is the reason 1 plus 1 will becomes 2. That's the reason we can sketch this particular y of t in such a way that this is y of t, and from 0 to infinite, this amplitude of this particular signal is 2. This is the way how addition operations will be performed. Now if you look at in both the cases, we have taken only the independent variable. This A we have taken because this is 1 and this is amplitude also. Only amplitudes we have taken into consideration. From minus infinity to 0, 0 plus 1 is 1. From 0 to 1, it is 1 plus 1 will becomes 2. This is the way how addition operation will take place. Similarly, even we can multiply. Suppose if I want to sketch, this is 1. Similarly, we can say it is u of t minus 1 and similarly third we can now y of t is equal to u of t into 1. Suppose if I want to sketch this minus, if I want to sketch this particular minus, so same, this minus this, so I'll say it is just minus. Now in that case what happens? Again same, first signal is, so I'm trying to explain you y of t is equal to u of t minus 1, u of t minus 1. So when I say u of t minus 1, so u of t is this, and 1 is this. So when I say u of t minus 1 in the sense, this is 1, 0, minus infinity to 0 it is minus 0, 0 minus 1 will becomes minus 1. So we will get it as y of t could be like this. This will be minus 1, this will be minus 1, because 0 minus 1 will becomes minus 1. Similarly from 0 to infinite, the first signal is 1, second signal is also 1. So 1 minus 1 will becomes 0. So signal looks like this. This is the y of t. Similarly we can also sketch y of t is equal to u of t into 1. So if I try to multiply u of t, what happens? Like this is minus infinity to 0, this is 0, 0 into 1 will become 0. So u of t is multiplied with 1, so we'll get the same signal as u of t. Just simply multiplication. Minus infinity to 0, 0, 0 into anything will becomes 0. So that is the reason it will be 0. Y of t will be 0. Y of t will be 0. Y of t will be 0 from minus infinite to 0. This will be 0. And from 0 to infinite, this is 1 and this is also 1. So 1 into 1 will becomes 1. So again you will get the unit step function. This is the way how signals will be drawn. Now this is all about addition, subtraction, multiplication. Very simple example I have taken to explain you how two signals are added and how one signal is subtracted from other signal and how two signals are multiplied. Similarly, amplitude scaling also we can try to understand. When I say coming to the amplitude scaling, say it as y of t is equal to a into u of t. When I say a into u of t or x of t, a into u of t, Now how do you represent this y of t is equal to a into u of t? This y of t is nothing but, like u of t, we know already u of t is equal to 1. U of t is equal to 1 when t greater than or equal to 0, and this is 0 when t is less than 0. And the representation of this particular function will be like this. This is u of t, and this is 1, and this is 0, and this is t. This is the way. Now for this, this particular function a is an amplitude. Suppose if I say y of t can be sketched as the amplitude of this unit step function is given as a. This is a. This is the way how this particular signal will be sketched. So we can scale this amplitude depending upon depending upon the situation. This a is nothing but amplitude scaling factor, we call it as amplitude scaling factor, we call it as. So we can have different values. Suppose if a is equal to 10, the signal looks like this. Then amplitude is 10. This is y of t, 0, and this is t. And similarly, if a is equal to 100, we can also sketch the signal as this is 100, 0, and this is t, and so on. So this is the way how we can scale this amplitude by giving the different value for this particular amplitude, and we can reduce. If a is equal to 1, this will be this will become this. If a is equal to 1, it represents a unit step signal. If a is equal to 10, we are increased. If at all I want to further scale the signal, A can be increased to up to 100. If that is the case, the signal can be represented in this way. So this is the way how the operations, how the dependent operations, how two signals are added and how one signal is subtracted from other signal, and how two signals can be multiplied, and similarly how signals can be scaled in terms of amplitude. If you look at all these things, all these operations focuses on only on the amplitudes or magnitude of the signal. So maybe in the next video we'll try to also understand how the operations on independent variables will be performed, that is time folding or time reflection, time shifting and time scaling. This is the way how signal operations can be performed on the different signals, and this is important once if the signal is given, like how to identify dependent and independent variables. Based on that, this operations, what are the operations on dependent variables and what are the operations on independent variables. Thank you.